So we're going to look at two more functions. We're going to look at two examples of a square root function and one of a reciprocal or inverse function. And so their forms are about the same. So you've still got your a value on the outside, you've got your h and k, h on the inside and k on the outside. And so my starting point, h is always opposite, so my starting point is going to be -4, -3. And you can look at that a couple of different ways if you plug it into Desmos or your calculator. We see that it does indeed start over here at -4, -3. If you go to your table, you'll have errors all the way until you get to -4, -3. So we're going to use that table and graph. I'm going to pick some whole numbers, and then we're just going to sketch the overall shape. So it looks something like that. And so my domain is left to right. The left of my function is at -4, and it continues on forever in the right. My range is bottom to top. The bottom of my function is -3, and it continues forever in the positive direction. It goes up forever. This entire function, if I trace it from left to right, is going uphill, so it's going to increase the same as my domain, and it never decreases. It does cross the x-axis, and it's somewhere between -1 and -2, it looks like. I think I sketched it a little bit different. So I'm going to actually find it exactly using my calculator. And you don't have to know how to do this, but I just want to make sure we're pretty accurate with these. On Desmos, you just point and click. So I've got a 0 at -1.750. So that'll help me with my positive, negative. If it's above the x-axis, which is this region right here, that would be from -1.75 until the end of the domain. And it's negative from the beginning of the domain, so at -4 until we reach that x-intercept. My end behavior on the left-hand side, I'm going to actually come to a point. So as x approaches -4, f of x, or that y value, is approaching -3. And on the other side, x is going to approach positive infinity because it goes on forever. And f of x is going to also approach positive infinity because that arrow is going up. So those are your characteristics there. If we look at the next example, it's already graphed out for us. We know some things about this function, the transformations in general, that negative is a reflection over the x-axis, the 2/3 is a vertical compression. We go to the right 4 units and we go down 5 units. So my starting point, even if I didn't have the graph, opposite of h, so opposite of -4 is +4, and k, which is -5. So for -5, we're good. Let me scoot that over. The domain is left to right, so the left side of my function starts at 4 and it continues forever. The range is bottom to top, so the bottom is -infinity and it stops at -5. This entire function is decreasing. We're going downhill, and so it decreases the entire domain. There are no zeros or x-intercepts. It's not positive at all. It's all below the x-axis, and so it's negative across the entire domain. And then my end behavior as x approaches, so this left side, as x approaches 4, f of x approaches -5. And on the right side, as x approaches positive infinity, f of x is approaching -infinity because that arrow is going down. So those are two your square root functions. We've practiced a lot with those characteristics. And then lastly, we've got a reciprocal function or a rational function or an inverse function, however you want to look at it. So we've still got our h here and our k here. Those actually tell me the asymptotes. So we've got an asymptote when x is 3 and when y is 2. So asymptotes are vertical or horizontal invisible lines on your graph. And so I'm going to graph both of those. So x is 3. So that would be your vertical line. And when y is 2, which would be your horizontal line. And to think about that just a second. They're supposed to be dotted, but my green doesn't work super well. So we know that those lines, that graph doesn't cross. And so the two pieces of it fit nicely between those asymptotes. My domain is all possible x values. We know at this asymptote, when x is 3, that my graph doesn't exist. So we are going to take that out of the domain. So we'll have negative infinity to 3 and 3 to positive infinity. And my range, same thing, it's bottom to top. It exists everywhere except for that asymptote. So when y is 2. So we'll have negative infinity to 2 and then 2 to infinity. This entire function, if I trace it left to right, even in the two pieces, both pieces are going uphill, so it's the same as the domain. So we'll have negative infinity to 3, union 3 to infinity. And we never decrease. We have 1, 0 at 5. Positive is a little bit tricky, so we've got this piece over here that's positive and this piece all the way over here that's positive. So we're going to be positive from the beginning of the domain until we get to that first asymptote, so until 3. And then we pick up being positive again after this asymptote and after we get to that x-intercept. So we start being positive again at 5. And that's really tricky. And it's negative just this little piece right here. So it's negative from that asymptote, so from 3 until we get to that x-intercept, which is 5. And so you'll notice that the positive and negative intervals together make up the entire domain. End behavior, both ends of the function continue forever in the left direction and the right direction. So we're going to say as x approaches negative infinity, f of x approaches that horizontal asymptote. It approaches 2. Can't count. And then as x approaches positive infinity, f of x approaches 2 on the other side, that horizontal asymptote. So those are your other parent functions. You've got h and k still occurring in the equations. You've still got transformations happening. You're still able to identify those same characteristics.